for what you're seeing, all glowing in there. We've got helium, neon, argon, krypton, and xenon. And where do you find those on your periodic table? Oh, and good morning, Isabel and Miranda. Welcome, Daniela. Hello, Jacob. So where do we find these on the periodic table? Yeah, they are on the far right-hand side. Do you think they have similar properties? Oop, this way. Do you think they have similar properties? Yeah, and Rukai's got the reasoning behind there. Yes, because they are in the same group. Does anyone know what this group is called? Think ahead. Yeah, these are the noble gases, and you might have learned about those before. They're like nobility. You know how nobility is kind of separated out from everybody else in the kingdom, and they don't interact too much? Well, the noble gases don't interact either. They're very stable. They don't form bonds with any of the other elements, etc. But they do make these nice, beautiful colors when you send electricity through them. And that has to do with their electrons. Remember, their electrons were in all those different levels? Well, if you add energy into an atom, it gets the electrons all excited, and so they jump up to higher energy levels, and they can't stay there because that's unstable, so they fall back down, and when they fall down, they emit light, and we get all these different colors of light depending on where the electrons are jumping to. So just some little tidbits about making light. It's magic. All right, so these have low pressure inside, filled with those noble gases, and the power supply, 5 kilovolts, that's 5,000 volts, 20 milliamps, that's your current, and 25 kilohertz, that's your frequency. 25,000 hertz, 5,000 volts. A couple of vocab words there for when we get to some physics and electricity. It can, but it's not the voltage that damages your heart, it's the current. And 20 milliamps, if that was to go through your heart, I don't want to say the wrong thing. That may or may not be fatal. If that was 20 amps, it would be fatal. I don't remember if the cutoff is 100 milliamps or 10 milliamps. Fatal or not fatal through your heart. Anyway, we'll get to that in February, March, somewhere around there for electricity, right at the end of our content. All right, remember to participate in all classes, attend all required classes, read and respond to emails, complete all assessments. And I will take one of these bullets today. Make sure you're logging into Clever on a daily basis, and then you go from Clever, link out to all your different places that you go. And also follow your calendar on Canvas and attend all your classes. All right. Code of conduct. Thank you guys for always following a good code of conduct, being respectful, being on time, not sharing your personal information. Oh, let me do a pre-test check real quick, see who else came in. Good morning, Jordan. Let's see, I need Allie, Ashler, Dakota, Carrington, Brittany, Caitlin, Mason, Naisa, Constantine, Imani, and Elizabeth. Hey, Seth, how are you today? Good morning, Nigel. Hey, Kessler, what's going on? And hello, Joseph. All these, yeah, I said hi to Jacob. I'll say good morning to you again. All right, so no pre-testers here. Moving on. All right, let's do a practice. I got out my cookies for this one to talk about which is true about the alkali metals. So use your emojis down there in the corner. Which is true about alkali metals? And Joseph, you have a question? Do you want to pick up your mic? Or you can send it to me in a private message. All right, Joseph, no problem. And hopefully you guys all have your periodic table someplace that's easily accessible. I'm waiting for a couple more answers. I'd love to know what Amanda thinks. And Isaac, Jacob, Jordan, what do you guys think about this question? And Quentin, Nigel, Miranda, and Maya, what do you all think? Thanks, Isaac. Seth, you can. This is the copy that you will use on your end of course test. So I would really prefer that you're using this one. Or if not, find one that's like black and white that doesn't have all those color codings. Because you can't use all the color coded one on your quizzes. But this one is available, and you can just download it, save it to your computer. It's in Canvas, and it's one of those modules. It's right above instructional cycle 1. There's the periodic table, the quiz that says, yes, I took the pretest, and then instructional cycle 1. And good morning, Juliet. Good morning, Leilani. All right, so let's see about annotating. I can annotate once a day. Okay, so what's true about the alkali metals? Are they in the middle? What were these middle ones called? That big group. Those were called the transition metals, so we can get rid of that. Are they at the bottom? Weren't these part of the transition metals too? These are actually called the lanthanides and the actinides. The lanthanides are the top row and the actinides are the bottom row. So those are not alkali metals. Alkali water would probably be water that is alkaline, which means it's basic. And so it has a higher concentration of OH molecules, which tend to bond with alkali metals, like you'll have sodium hydroxide, or you might have potassium, oh, it's over here, potassium hydroxide, or lithium hydroxide. And when you dissolve those in water, you get an alkali solution. All right, so we've got group 1 or group 2. Remember, yeah, elements in group 1 had one name, alkali, and elements in group 2 had 2 names. They are the alkaline earth metals, alkaline earth. So there we go. And y'all should change your answer once you understand the correct answer. That way I know we're good to move on. So I should see a whole lot of smiley, happy faces. All right, looks pretty good. Oh, I have to unannotate. I'm looking for my button. Okay, so one more question. Let me clear these responses. All right, so what is the mass number of this krypton isotope? And 2 more questions. How many neutrons does it have? You know what? I just realized that the right answer isn't on here. All right, so let's ditch the answers. Was anyone wondering, like, where is it? Can I annotate? Let me try to annotate this one. No, no, it's not gonna let me. Look at annotate. Everything is the pretest slide. Okay, oh, now I'm here. Okay, so let's talk about the mass number. Sometimes I get a little tired when I'm working on these. What is the mass number? Let's just do this in the chat. The mass number, remember, things that have mass are protons, right, and neutrons. So that is always our big number. What is our mass number of this? Well, 36, you can see 36 is the number on the card here. That's its periodic table number. And the periodic table number isn't the mass. The periodic table number, right, the atomic number is going to be your proton. So that 36 is just the protons. So what's the mass number? Yeah, our mass number is the top number. It's always the bigger number is the mass. And then the smaller number is always going to be your atomic number. Okay, so our mass number is 86. That's our neutrons and our protons. Oh, that's a good question. Why is it not 86 on your periodic table? It's 83.8. And on the periodic table is an average mass of all the isotopes at all their abundances. So probably 84 is the most abundant isotope of krypton. But this particular isotope has 2 extra neutrons, and it has a mass of 86. All right, I think we cover that more a little bit later too, but I'm not sure. I bet we will look at that. Okay, so if you have 86 neutrons and protons, and this is atomic number 36, how many neutrons do we have? Well, we have 36 is our atomic number, right? We had 36 protons and 36 neutrons, then our mass number would be 72, right? 36 plus 36. I think it's a little more than 18, but less than 72. Let me see. I'm going to clear. Let me get the whiteboard here. Let me see if I know how to do this. Okay, so let me write on the whiteboard. Here we have, so we have 36 protons. That's a 6. Plus, we don't know, so I'm going to do X neutrons, and that's going to equal 86. Can you all see the whiteboard? Okay, yay, you can see the whiteboard. All right, so if we subtract 36 from both sides, that'll get us our answer. Right, and then we have the neutrons equals hey Giovanni. Oh, come on guys. How many neutrons do we have? 50. Yeah, so it's a subtraction. Cool. And Giovanni, you have taken my pretest, so that is fantastic. All right. My list of students big enough that I can see all of you guys. So what questions do you have about this one? Because those, I'm sorry, those answers were not right. Yes, Rukiah just put in the chat the whole summary of what we've got here. And good morning, Kate. All right, so what other questions do you have? You're welcome to pick up the mic. Or you can type in the chat questions. And good morning, Aiden. You find the neutrons by subtracting, but you also know that mass equals the protons plus the neutrons. And I was typing in equals, and I think I can use my tool and change the shape. Yeah, okay. I wonder if I can make it bigger. There we go. I could also make that as a note. Note title, atomic mass equals protons plus neutrons. There. All right, so that is also at the bottom of the notes on the note board over there. Okay. What other questions do you have about doing this? About finding the number of neutrons, the mass number from these little isotopes? Yes. Good morning, Olivia. And good morning, Jalen. All right, moving on. I don't see any more questions, but if you have more questions, we can talk about those once you have a little bit of work time today. The atomic number is just your protons. So the atomic number would be 36. Okay. The 86 is the mass. That's your protons and your neutrons. That's your mass. Okay. $50 is the neutrons. So let me type this down here and maybe that'll help. So our mass was 86 equals our protons 36 plus 50. Oops. I will get better at this. So it's right down there on the whiteboard. Are y'all able to see that? Does that help having them lined up together? Yay! Cool. I will work on typing more instead of writing on the whiteboard. My writing is not tip top of the line at all. So I just figured out how to resize everything. So I'll get better at typing on the whiteboard. All right. Yay! Are there any other questions? All right. So today our essential question is, how are nonmetals identified? And this guy is one of my kitties. That's Rocky. I only have two, but I just love that picture. Anyway, today is going to be a very similar lesson to what you guys did yesterday with metals, but now it's going to be about nonmetals. So you'll explore some of the characteristics, find out where they're located, and look at their reactivity. All right, so just a reminder here, with your mic or with your chat, tell me what color are the transition metals, the alkaline earths, and the alkaline metals. And then I'll let you go get started.
Red group is alkaline metal.
That is correct. The red group is the alkaline metals. So what color are the alkaline earth metals? Yes, they are the orange group. And so what color are all those transition metals? Yes, those are all the white ones. And that's the largest group on the periodic table. All right, and after going through the lesson, just wanted to let you know and remind you that we have this Explore and Learn More section if you want some additional support to your learning. The other colors we're going to learn about later. So far, we've just covered those 3 sections. So we'll get a couple more of them today. And if you feel like you want to learn more than what's in the content, you can go here to get some more in-depth links to things. That's okay, you don't have to use those. All right, so too much, huh? So remember, the note guides are there. If you have a PDF reader Adobe program, you can fill those in. And then you want to go through their little videos and checks. And remember, this check for understanding really is the best way for you to check if you got what's in the lesson. All right, so we will meet back in here after about 5 or 8 minutes before the end of class, which gives you about 12 minutes to work on this. So when you're ready to work, you can give me a green check and I'll put you in a breakout room. And if you have questions or you need anything, just stay here and this is my time to help you. All right, so change those to green checks. All right, thanks, Jacob. Just looking at that list again, making sure there are no pre-testers. Hey guys, I have brought you back from the breakout room and I am back recording our session again for those who missed class. And so anyway, questions that you had can go right there in the chat, or you could put them on the whiteboard. Hey, Cameron. So like Cameron, who missed part of class, you can go back and watch the recording to catch up on the front half of class. So questions. Oh, good question. Where do we find those recordings? And they are in Canvas. And let me just share real quick, because I think that's important. Oh, cross your fingers, the screen sharing is going to pop up here. So it's in your Canvas modules. It's the second module down. And I can show that to you right now. Okay, so here's my calendar. And if I go back to my dashboard, click on my physical science class, and then go to my modules. Here's the first module, and then the second module here are the class recordings. So if I open that up, here's this week. So there's the one from the 19th from yesterday, and that's your class. And then here's from the previous week. I look awful. YouTube doesn't give you many choices as to what pictures to choose. So that's the 12th, the 13th, the 14th, and the 15th. And then I just added this one this morning, so I'm all caught up on these. So that's from last Friday. This is the quiz review. So if you haven't taken the quiz number 1, watch this little YouTube video first. Oh, thanks, Rukaya, for catching that. And again, I went to modules. And then it's the second one down, class recordings. So pretty easy to find. I put it right at the top. And that's above, like, there's a periodic table, just in case you were looking for that. Did you take the pretest quiz? Cameron, I'm not quite sure how all that's working quite yet, but so you don't have to let me know. There's going to be some way that they're going to do that, and I'm not sure. Yeah, I'm not sure how they're going to do that yet, but they will do that soon. That will be coming soon. Okay, for right now, let's just review here. Thanks, Rukaya, for helping out there in the chat. We have 4 minutes, so maybe we'll just work on this one. So which group is highlighted? Question 1. And y'all can just put these in the chat, or you can pick up the mic. Yay, Julia, you can hear me again. So which group is highlighted? What's the name of that yellow group? It does have 7 valence electrons. So check, Seth has gotten question 4 correct. What's the name of it? Yes, the halogens. And are they brittle or malleable? Remember, these are non-metals, so they're going to have different properties from the metals. Remember, metals were malleable, so the non-metals are going to be brittle. So if you had a cube of chlorine, which would be very strange, it would shatter. If you hit it with a hammer, it would shatter into a million little pieces. Yes, Cameron is jumping ahead. They are poor conductors. What about their state at room temperature? Are they gas, solid, or liquid? I wouldn't pick liquid. However, bromine is a liquid. Trying to remember. All three states, that's correct. So bromine is a liquid. What about fluorine and chlorine? What state are they in? Well, I didn't really mean it to be a trick question. I'm all about those tricky. It's just a tricky question. So are they gas or solid up here at the top where they're nonmetals? The nonmetals are gases. And as you go down, it comes liquid. And then the bottom ones, this bottom one here, which is acetane, is going to be a metalloid. And we will get to those tomorrow. But the bottom ones, what state are these guys in at the bottom? Yeah, those are going to be solid. Yes, good guessing today. Good guessing. How reactive or non-reactive are these group 7 halogens, group 17 halogens? Yes, they are the most reactive nonmetals. And that's because how many electrons do they need to become stable? They start with 7, right? And how many do they need to get that octet? Yeah, they just need one more. So just boom, one more, and they are stable. So they react very quickly to gain that one extra electron. And if you want to stick around for a sec and talk about this, maybe I'll just go through it. This is the noble gas column, as we are at the end here. They have very low melting points. That's why they are gases. Gases mean that, yes, they are volatile. Volatile might make you think of like reactive and stuff, but that's a different definition. Volatile in chemistry is just that they are gaseous. So they evaporate very easily. They have 8 valence electrons and are completely unreactive. And they have a low melting point. They melt at really cold temperatures because they are very, very gaseous. So very volatile, but they are unreactive. So thanks for coming in today, guys. I have held you a minute too long. I'm sorry. Take care, and I will see you 4th period on Thursday. Tomorrow it would be any catch-up time you might have. Bye. Don't forget about map tests if you still need to make up language, reading or math is tomorrow at 2:40 with your HR teacher homeroom. Bye, guys.